Hey everyone, it's Mrs. Slauson. So we are on the last section of our notes, and I'm on the last page of our Chapter 2 packet. I'm on page 39. And the last thing we're going to be talking about before we end this chapter are called composition functions. So there are different operations in math. There's adding, subtracting, multiplying, which we did in the previous notes with functions. We added them, we subtracted them, we multiplied them. There's also division, but I cut that out of this chapter because we'll hit it in Chapter 4. But there's one more type of operation that's called a composition function. And essentially, when you're making a function, a new one, you're going to have two other functions, and essentially what's happening is you're putting one function into the other, and then you're just simplifying it, you're cleaning it up. And so you actually are very familiar with this, and I'm going to show you why you're familiar with this. So you have a function f of x. The function is 3x squared, and here's my function, and this means when I have a 4 in parentheses that it should go here. So what I tell my freshmen when they first see functions is we always draw this wall, and I tell them 4 is in parentheses, and they can envision these parentheses as hugs, and that means 4 needs a hug. And so when I'm putting 4 in, 4 is either going to go on the left side or the right side. And so if it goes on the left side, then it's all alone. And I don't want 4 to be alone. 4 needs a hug. So it's going to go where everything else is, where all the other numbers are. So when I do that, 4 is going to go in here. And instead of 3x squared, it's now going to be 3 times 4 squared. And then I just follow my order of operations to clean this up. So I do exponents first. That's 16. And then I multiply by 3, and I get 48. So when I'm done, my function, when x is worth 4, gives me an answer of 48. So you can do this as well, like this. And so we had a few of these in the beginning of the chapter. So here's my function again, same function, 3x squared. But this time, instead of just a 4 being in there, there's an x minus 4. But it's still the same thing. X minus 4 is going to have to go in for x, either the left side or the right side. Since it's in parentheses, envision that your function needs a hug. And it's going to go where all the other numbers are. So now it's going to be 3 times, and instead of x, this is going in its place. And what we want to do is clean this up. Our goal is to always get it into the best form of standard form, so there's no parentheses. It's all just addition and subtraction. So remember that this x minus 4 squared means there's 2 of them, and you've already done stuff like this. And then this is the neighbors meet the neighbors, and we've got 3 neighbors. Here's a neighbor, this is a neighbor, and this is the neighbor, and I just need 2 of the neighbors to meet. So I always start with the parentheses, and when I start, I get x squared minus 4x, and then this is going to distribute through, and I get another minus 4x, and when this distributes, I get 16. I'm going to add them up. I'm running out of room, so I'm going to move up here. I get x squared minus 8x plus 16, and then I still have the other neighbor who hasn't met anybody. That's the 3. And now the 3 is going to distribute in, and so when I'm done, my final answer to the function is 3x squared minus 24x plus 48. And I would normally put it after this equal sign, but I don't have any room, so I'm just going to put a box in there. So you've seen this before. We've put just a number in for the function. We've put something a little bit bigger in there, and now what's going to happen is we're going to have a whole function and put it in to the other function. So in these couple problems, so first we have f of x, which is 2x squared, and we have g of x, which is x cubed. And what I always tell my students is you have lots of parentheses here, so take the most outer ones and really make them stand out like that. And what this means is normally where I would put 4 into f of x, this is saying I'm going to put g of x into f of x. So basically g of x is x cubed, so what's going to happen is g of x right here is x cubed. It's going to go in like that, okay? But essentially g of x is going right there where that x is, and that's what this is saying. So when I do that, it'll be 2 times, and in for x will be x cubed. I always put it in parentheses, and then I still have that squared. And then again, I just want to clean this up as much as I can. So I have the 2, and the squared means there's 2 of these x cubes. And then I can clean these x's up, simplify them by making them x to the 6th. So when I'm done, my final answer is 2x to the 6th. Okay, so again, whatever in the parentheses, that's what's going here, like this. So I'm going to kind of show it to you a couple of different ways. So let's skip this part down here for now, and let's just try another one. So this time I have two functions, g of x, 2x squared, and I have f of x, which is x plus 3. And when you see something like this, again, I'm going to make those outer parentheses stand out just a little bit more. This is saying, just like I put 4 into the function, or x minus 4 into the function, this is saying put f of x into g's function, which means all of this is going right in for that x. So the way I would write that is g and then f of x, which is x plus 3, goes in its place. And then it kind of looks like it did up here. But again, it just means that all of this is going in here. So all of this is going right there. So we'll have 2 and then x plus 3 squared. And again, I just want to clean that up. So I'll have 2x plus 3's. And now this is just the neighbors meet the neighbors. I always have the parentheses go first. So there's x squared and 3x. And then 3 goes to meet. I get another 3x and 9. So right now I'm at x squared plus 6x plus 9. And then I don't want to forget about the 2 that was there. So the 2 is going to come down and distribute in like this. So when I'm done, and I'm running out of room, so I'm going to squeak this in right here, I have 2x squared plus 12x plus 18. So again, it's something that you know. It's just where you take one function and you put it into the other one, and then you follow the math to simplify it and clean it up. So let's take a look at these two problems, and then we'll stop the notes and come back together as a class. So when you see something like this, you got a couple of different ways to do this problem. So I think I'm going to show you maybe what I think is the simplest thing. So again, I'm going to start with my outer parentheses, really make them stand out. And what I want to focus on is what's in the parentheses, because here I'm actually going to be evaluating a number. So what I do is I start in the parentheses, because remember, you have lots of parentheses. You always start with your parentheses first. That's what order of operation says. So basically, I can just ignore this f, and this says take 2 and put it into g's function. So I'm going to take 2 and put it right in there. So I'm going to start there. So I get 2 cubed, which just means 2 times 2 times 2, and that's 8. So when I'm done, g of 2 is worth 8. So all of this is worth 8. And now I'm going to bring the f back, and now I'm going to do the second step to the problem, which says now take 8 and put it into f's function. So I'm going to take 8 and put it right in there. So that becomes 2 times 8 squared. So don't multiply first. You always do exponents before multiplying. So 8 squared is 8 times 8. That's 64. And then when I multiply those, I get 128. And that is my final answer. So let's try this one. So again, I'm going to take those outer parentheses, make them really stand out. This time we're using these functions up here. So if I start with the parentheses, I do what's in the parentheses first. And this is saying take negative 2 and put it into f's function. So I'm going to take negative 2 and just put it into here. So when I do that, here's negative 2 plus 3, which is 1. So when I'm done, this function, when x is negative 2, gives me an answer of 1. So this is just replaced with 1. And then I'm going to come back, and now I'm going to do the second part, which says now take 1 and put it into g's function. So I'm going to take 1 and put it right in for there. So it's 2 times 1 squared. Again, do your exponent first. 1 squared is 1. 1 times 2 is 2. And so when I'm done, my final answer for this is 2. Okay? That's where we're going to stop as far as the video notes go. We're going to come back together as a class and take a look at the rest of the problems.